Hello guys, welcome to today's session. We're going to go through backend and a little bit of cloud computing. My name is Jen Fadhili, and if we go through this session and you have any questions, just post them on the comment section and I'll answer where I can. In the previous sessions, you learned about how to navigate the Visual Studio, how to use Git and GitHub, and I'm positive that you learned about the front end and the visual stuff. So today we take a in-depth of the back end and a little bit of the cloud computing. So why backend? When you have like a web static page, the portfolio for everyone that you have to have the one that has your name, the one that gives your interests and everything of that sort. You don't need a backend. You can have a backend, but it can be in your laptop because it does not require a lot of space. So that can be in your computer, and if you have internet, it can be accessed anytime by anyone. But today we are going to talk about the backend that big apps require. So we need backend because it saves and manages our data. For example, in YouTube, you can have it saves data like your search history, your sign up history, sign up information, your login information, your watch history, and it can also save the recommendation so that when you close the YouTube app and open again, the same recommendations that you had, they still appear because they have been saved in the backend. So what exactly is backend? What exactly is the backend? Mainly is the server. And in the server, we have the programming language, we have the framework, and we have the package managers. So the programming languages that are used in backend, we have Python, we have Node.js for JavaScript. That's why we say JavaScript is both front end and back end. And then we have Java and we have Ruby. And with every of this language, there are different syntaxes that you have to use. For example, we have a sign up for YouTube over here. So you can see that we used Python to create this whole page. We have email, password, config password, confirm password, and the like. So um, that is just the syntax for Python. And then we have the frameworks. So each language has its own framework. For example, Python, you can have the React framework and also Django framework. So you choose either one of the two. You have Ruby on Rails for Ruby. We have Express.js for Node.js. We have Spring for Java. So why do we need framework if we already know the programming language? We need the framework because a framework compresses the code. It makes the code smaller than it would be with if you write with a whole language. As you can see here, it's just a small thing and it's direct to the point, and it helps you to also extract information from the front end. Here you can have something, say this form, where will it be extracted, and you put the URL just before the user sign up request. Yeah. All right. So we look at packages. Packages are code that other people have written and it's open source. Like if you go through the Lex course, you see that we always import time because it's already written. Mathematics, it's always written by someone else, so you don't have to start writing everything. You just have to edit a little bit of the code so that it goes well with the rest of your code. But otherwise, that is what we call packages. And even the installation, when you want to install a program, you don't need to go and write the whole code so that you can install, because that is already written by the people that came up with the what that came up with those languages. So for example, when you want to install and manage the packages, like you want to install Python, you'll use pip. And then when you want to install Ruby, you'll use bundler, and PM for Node.js and JS, JavaScript, and Maven for Java. Don't need to go and start thinking, oh, how am I going to write the code so that I can install? You don't need to do that. It's already done for you. All right. Okay, guys, I forgot to talk about web servers because some of the frameworks like Django don't really, they can serve the pages for you. They can connect both the back end and the front end. But in some cases, you might want to use Nginx or Apache server so that they may connect the front end to the back end. That's why I had forgotten to include it and just talked about the framework. Okay, moving on. Right. So far we have looked at the web server. So from the web server, where do we save these things? Yes, we've seen that we have to write the code for so that everything can be saved where everything can integrate well with the client. So where do we save? That's where the database comes in. And the database is just a systematic collection of data. It's not random, it's systematic. It comes how it's supposed to be, and it shows if you want to store email addresses, put it in this space. If you want to save credit card information, put it in this other place. So it's just used to store and manage your data. And if it comes in a systematic way, then it will use the data management system, DBMS. It helps you. It's just a program that helps you to manipulate the data, to represent the data, and even access the database, so that if you don't want someone to access credit information for another person, you can restrict that person, but you can see. So not everything is accessible for everybody. And there are different types of databases. We have MySQL, MongoDB, Postgres, SQL, and most of these use the REST IP. So here is an example of how to store the data. For example, if you want to log in, you use the type get and then www.youtube.com. So this youtube.com is the URL, and then the login is the path. So when you do something of this sort, you use get and the like, it shows you what is supposed to be done. Get is used to retrieve the information that was there before. So if you wanted to register, like if you wrote here, instead of login, you wrote register, then you will have to use post so that it creates a new user. So the REST API is representation state transfer. It's very simple, and that's why most of the people who do backend use the REST API. And API just means that you've just told this computer, this server, this database that you take this language, you take this framework, and you can handle this request, and you are not supposed to take this. So if a person writes a password that does not have numbers and letters and the like, do not allow that. If a person wants to retrieve something, like here you say get, so it's going to take, if that command get is allowed and this user is allowed to take this information outside, then that API will agree to give out that information. That's basically what an API is. If, like, how are you supposed to handle this request, and what requests are allowed and what requests are not allowed. Now that is called an API. And then the REST API has the following types. So we have get for getting something that is already in the database, post for creating a whole new thing, like a whole new resource, and then put, you replace, and you replace whatever that was there, you replace it totally. And then there is patch, which replaces it but adds some properties to the resource. And then we have delete, obviously to remove something from the database, and head. So all this is called the CRUD method: the read, the create, read, update, and delete. So far we've talked about the frameworks, we've talked about the programming language, and we've talked a little bit of about the database. So we're going to look at the cloud computing. So here you can see I have written infrastructure. This is infrastructure as a service. This is when you have data and you have so much traffic, and you have sensitive information that you might not want in the reach of other people's hands. You might want to put it in a secure but big space that can accommodate everything, and can accommodate the traffic, and can accommodate everything you want to add to your server, everything. That's why we have the clouds here. So here AWS is for Amazon Web Server, and then we have Google Cloud Platform, and then we have Microsoft Azure. These are the three main cloud servers that most people know about, and most people will want you to have if you want to go to do cloud computing. And in the cloud computing is just like a big computer that can do all this crazy work, and then they create a lot of virtual machines. These are machines that are just somewhere, so you just come and take one small virtual machine, and then you make it yours. You customize it to your needs, to your business needs, to your application needs. That's basically what infrastructure as a service. So they offer you this service because they know you cannot have, okay, you know that they know, but they assume that this power that they have, they can share it with you at a small cost. So what happens, for example, in YouTube, when a video goes viral and everybody wants to see it? If you only have one virtual machine or one server, it will be very hard, because it will be glitching, because everybody wants a piece to see something, wants to see this thing, wants to see. Therefore, we need to have several virtual machines, and we have to have a load balancer over here, so that load balancer can spread this cost, this traffic evenly around this web server, these web servers. And these web servers can be the same. You just take one and you duplicate it, and if you need another one, you also duplicate it, and that can be made easy by using platform as a service. So rather than just going and copying all your code that you had written, because if you're using a load balancer, it means that the web servers must be the same, must be a copycat of the other. So rather than just coming and manually trying to copy, manually trying to set things up, manually trying to program, it will be hectic. That's why we have platform as a service. This is where a company offers you to, they let you upload the previous backend that you had written for one virtual machine, and then they will copy all that for you and set it up for you, so that if you need two of them, they will copy them to and make two of them, of course at a service. For AWS, you'll get AWS Elastic Beanstalk. Google Cloud Platform, you'll get App Engine, and Azure, you'll get the app service. So they make work easier for you, so that rather than stressing about so many things, they specialize in one thing for you. Okay, so now we go to the last part of this session. It's called the software as a service. So we've looked at infrastructure as a service, we've looked at platform as a service, and now we are going to look at software as a service. As the name suggests, it is just a software. So if we look at the tasks that we used to do in LX, for those that were in LX with us, you know that our codes are usually broken down into smaller pieces. For example, if you're going to build a login, the one question will be about login, the next question will be about help you with the credit transfer, the next code base. So it will not just be one. So rather than having a long code, you can break up the different tasks into different code bases. So that, like for example, in YouTube, we looked at the credit card charge that for premium members, and then you have email confirmation, and then you have search history, watch history, recommendation. All those can be different code bases. So you split them into four code bases, or five, and then each code base can even have its own backend. That way, the requests will not mingle with one another. If it's email, it just goes to email. It becomes easy and efficient because each and everyone can even have its own backend, so they do not interact that much, and they do not cause confusion. It becomes more focused, it becomes superfluous, it becomes smoother to run. That's where we need software as a service, and we have many softwares that can be used. For example, if you wanted to have an email confirmation, email service code base, you can even have like an app like Twilio that gives you that service. So you just pay them a little bit, and then they provide you with this email as a service, so that you don't have to come again and start setting up your own email services outside. If you don't want to, you can give different services to different softwares. And that is it. In this session, we have looked at the backend, we've looked at the server, and we've looked at in the server how you need the framework, you need the package manager, you need the programming language. We have also looked at the different databases. We've looked at how you can manage it. We've also looked at cloud computing, and we've seen that if you need to delve into cloud computing, you need to know the infrastructure as a service, platform as a service, and software as a service. Yes, and I hope that by the end of this session, you'll have at least made up your mind whether you want to go to front end, whether you want to go to back end. But I hope you guys will choose back end, so that I can see most of you. But anyway, it has been good, and I hope if you have any question, just contact me on any social at Jen Fadhili, and you can also leave your comment in this in the comment section below, and let me know if you are going to come to our side of backend.